Okay, so the next topic we're going to talk about is learning and forgetting. And the first type of learning we will talk about is non-associative learning, which is not super high yield, but it's pretty easy. So I definitely think you should know it for the MCAT. So non-associative learning occurs when an organism is repeatedly exposed to a stimulus. Excuse me, and the two types that may appear on the MCAT are habituation and sensitization. So these are always the two that you're going to hear about when we're talking about non-associative learning. It's going to be habituation and dishabituation, and then we have sensitization and desensitization. So let's talk about habituation first. And that's when an organism learns to tune out a repeated stimulus, or when the response to a stimulus decreases due to repeated exposure. So it's that really happens. This happens to us all day, every day. So imagine if you enter a house where someone just baked cookies. As soon as you walk into the house, you're going to smell the vanilla, you're going to smell the chocolate chips really strong. But after 5 or 10 minutes, you're not really going to smell anything new anymore. It's just going to go, your nose is going to go blind. So that's what habituation is. We're sort of turning out a repeated stimulus because we're constantly exposed to this smell. So at a certain point, our body just doesn't really have a need to respond to the stimulus anymore. So we do learn to tune it out, and that's called habituation. Dishabituation is sort of the undoing of habituation, and it occurs when the stimulus is removed. So if we're talking about our cookie example again, once we leave the house, we're not going to be smelling cookies anymore. So we are going to become dishabituated to that stimulus, which is the smell. So when the organism is again presented with the same stimulus after dishabituation, it will react as if the stimulus is new and may elicit even stronger response. So that means after dishabituation, after we leave that house, when we come back in, habituation can occur again. So we're going to react as if the stimulus is new, so as if we've never smelled it, and we might even elicit a stronger response when we smell it, just because that's just how dishabituation works. And then the other sort of opposite of habituation is sensitization. So when an organism elicits an increased response to repeated stimulus exposure. So habituation is when the response decreases with repeated stimulus exposure. Sensitization is when it increases. So it's essentially the opposite of habituation. And then desensitization is the same thing. So like the opposite of sensitization. It occurs when the stimulus is removed. The organism will then react to the stimulus as new. So for example, one of the better examples I saw for this was if you're watching a horror movie, you are going to be sensitized to those sort of scary stimuli and those sort of jump scares. So if you're done watching a horror movie and you leave, and one of your friends is waiting outside of your door and tries to jump and scare you, you are going to be a lot more scared after watching the movie than you would be before watching the movie, because you're sensitized to it. You have had an increased exposure to these sort of scary jump scares all day, so now you're sensitized, and you're going to actually elicit a stronger response to a similar stimulus. And then desensitization, obviously, say you go to bed and you wake up the morning after, you're going to be desensitized, because as time passes, we pretty much desensitize to stuff like this. And then once desensitization occurs, sensitization again is possible. Okay, so we talked a little bit about non-associative learning. So now associative learning, which are the really important types. So the first one is classical conditioning, which I'm sure we've gone over. This little diagram to the left is the most popular example, Pavlov's dog. So the first type of associative learning is classical conditioning, and that's a process in which two stimuli are paired such that the response to one of them changes. So if we look to the left, we have before conditioning. So we look at the top left, this box right over here. We have an unconditioned stimulus, which is the food, and then the unconditioned response. The unconditioned response is what happens when the dog is exposed to the unconditioned stimulus. So this is usually like something instinctive or something inherent. So food is the unconditioned stimulus. It's going to cause the dog to salivate, which would be the unconditioned response. We didn't teach the dog to do that. It's just on a biological basis. This is the response that the stimulus is going to elicit from the dog. We then have a neutral stimulus. In this case, it was a bell. So every time Pavlov would feed his dogs, he would ring a bell. So eventually the dogs learned to associate the bell with feeding, and they would salivate before food was even given out every time they heard the bell. So before the actual conditioning occurs, the bell is considered a neutral stimulus, because if we ring the bell and the dog has not learned to pair it with food, there's not going to be a response. The dog will not respond to the neutral stimulus. That's why we call it neutral. So during conditioning, we take that neutral stimulus and we pair it with the unconditioned stimulus. So every time we ring the bell, we're going to give the dog food. That unconditioned response is going to be in response to the food. But since we're pairing the food and the bell, after conditioning, that conditioned stimulus, the bell, is going to elicit a conditioned response, which is salivating, just from the bell alone. So that's how classical conditioning works. It's just basic association of two stimuli. Yeah, so the neutral stimulus becomes conditioned and that elicits a response. So the sound of the bell alone will eventually cause the dogs to salivate. Okay, and then associative learning. So these are just some important words and phrases that you should understand. So when we say acquisition, we're talking about the process by which an organism pairs two stimuli to form a conditioned response. So acquisition is the actual act of pairing the stimuli. Extinction refers to the process by which a conditioned response is unpaired from its stimulus. This usually occurs by presenting the conditioned stimulus repeatedly without the unconditioned stimulus. So if we're talking about our Pavlov's dog example again, acquisition would be the process by which we are pairing the food with the bell. So that would be acquisition. So once we get that neutral stimulus of the bell, once that becomes a conditioned stimulus, we would say that that behavior was acquired. The salivation from the bell was acquired. And then extinction is the opposite. If we continuously ring that bell and we don't present the dog with food, eventually the dog is going to learn to unpair these two stimuli. So extinction, eventually we would ring that bell and the dog would stop salivating because it would know that there's no food coming anymore. And then spontaneous recovery, interestingly, is the spontaneous reacquisition of a conditioned response to a stimulus after it has gone extinct. So this does not involve acquisition. This is just something that happens after a behavior is felt to be completely extinct. It will randomly and spontaneously just recover, which is very interesting, but that's just how it happens. Generalization is the process by which a conditioned stimulus is broadened to the point where similar but distinct stimuli cause the same response. So generalization, if we're using a specific bell to get these dogs to salivate, if the dogs salivate when they hear something else similar, like a phone ringing, or if they start to salivate when they hear silverware clinging together, that would be considered generalization because we're broadening the stimuli that caused that response. We're adding more stimuli that would cause that response, whereas discrimination is the exact opposite. So that's when we're trying to differentiate the stimuli. So if we had those three, if the dogs reacted to the cell phone, to the actual bell, and to the loose silverware, and we wanted them only to react to the bell, we would play all of those. We would let all of those stimuli, we would let the sound come out, but we would only pair one of them with the actual unconditioned stimulus, with the food. So if we did that with the bell, eventually the dogs would be able to discriminate between the three stimuli and know that only hearing the bell means that they're about to get some food. So that is considered discrimination, and that's how you would teach discrimination. So associative learning, we have operant conditioning, which is the more complex of the two types of associative learning. So what operant conditioning does is it molds behavior using reinforcement or punishment. So there are two types of each, and it's important that you conceptually understand the difference between reinforcement and punishment, and also understand the difference between how we're using the words positive and negative. So in the context of reinforcement and punishment, this is very important. Positive and negative have nothing to do with the actual pleasure of the outcome. They have nothing to do with the fact that it is either a good outcome or a bad outcome. When we say positive, as in positive reinforcement or as in positive punishment, it means we are giving something. So in positive reinforcement, we are presenting a reward. In positive punishment, we are presenting a punishment. So when something is negative, it means we're taking away. So for negative reinforcement, we are taking away an undesirable stimulus. And during negative punishment, we are taking away a desirable stimulus. So we're going to go through each of them individually so that we can sort of process just exactly what that means. So we'll start with positive reinforcement, which is the most, probably the easiest to understand conceptually. And it's basically just a reward is presented to the subject after a desired behavior is performed. So they say you're trying to teach a dog to sit. Whenever the dog sits, you give it a treat. That's positive reinforcement. That's really all it is. We're just adding a desirable outcome I'm sorry, we are presenting a reward every time we see a desirable outcome. So our desirable outcome in this case is that the dog is sitting. When the dog sits, we give them a reward. So negative reinforcement is we are taking away an undesirable stimulus. So it's the same goal as positive reinforcement. We are trying to reinforce a specific behavior. We are trying to keep the behavior. Positive reinforcement, we're giving them a reward. Negative reinforcement, we're taking something away that is undesirable from them. So if we have a dog again, say we're letting our dog out right before we go to bed, and it's raining. So the dog is outside and is getting really wet and wants to come in, but you're not going to let the dog in until it pees. So that's sort of negative reinforcement because the dog does not want to be in the rain. So the dog will learn once he pees, he can come back inside. So that would be considered negative reinforcement because we're taking away an undesirable stimulus as a reward. That technically would be considered our reward. So we want that behavior to be performed. So that's what negative reinforcement is. Punishment is sort of like the other side of the coin. It's the process that discourages a behavior by pairing it with an unpleasant outcome. So it can also be positive or negative. So punishment, if the dog does something bad, positive punishment. We put the dog in the cage, say. I'm not a dog trainer. I'm not saying that that is a good thing to do, but I'm saying for our example, positive punishment, we are adding an undesirable stimulus. So they do something wrong, we put them in the cage because we know they don't like the cage. During negative punishment, we're taking away something that's good. So use an example of a kid, say the kid does really bad on his test, and his mom takes away his video game privileges for a week. That would be considered negative punishment because she's not adding a punishment to him. She's taking away something that he likes. So that is considered negative punishment because we are trying to discourage that undesired behavior, whatever he did. So if he did bad on his test, negative punishment, we're taking away something that he likes for a little bit because we're trying to get rid of that undesired behavior. And then just really quickly, we have primary and secondary reinforcers. So primary reinforcers are unconditioned stimuli, like we spoke a little before, that are inherently desirable. So those usually have like sort of biological connotation. So it's usually food, water, sex, sometimes sleep. Those are primary reinforcers that we don't need to condition. And then secondary reinforcers are conditioned stimuli that are paired with primary reinforcers to become desirable. So for example, coupons to your favorite restaurant. If you're presented with them, you don't know what the restaurant is, you don't even know what a coupon is, you're not going to really care about it because you don't know what it is. You don't understand the value that it holds. But if you really love the restaurant and you understand what these coupons are and you're going next week, they're going to be a pretty strong reinforcer because, it's context and it's something that you want at that point. Okay, so reinforcement schedules we'll talk a little bit about. So there are different reinforcement schedules on which operant conditioning can occur successfully. So this is just the way someone chooses to carry out operant conditioning. So on a continuous reinforcement schedule, the behavior is rewarded after every occurrence. So when I say occurrence, I mean every time the behavior happens. This schedule will result in very quick acquisition of a behavior, but it can also result in quick extinction. So if you reward the dog for sitting every single time, they will probably get it in a few days. They'll probably learn it very quickly. But if you stop giving the dog treats every time the dog sits, it will forget the behavior very quickly. Is basically just what continuous reinforcement schedule is. Whereas we have intermittent reinforcement schedule as well, the behavior is rewarded only after some occurrences, but not all. So this schedule results in slower acquisition of the behavior, but the learned behavior will persist. So it's going to resist extinction for a lot longer. So that would be if you teach the dog how to sit and you give them a treat every fourth time they sit. That would be considered an intermittent reinforcement schedule because you are not presenting a reward every single time the dog does it. You're only presenting it intermittently. And this intuitively, it results in slower acquisition of the actual behavior. But once that behavior is acquired, the organism will hold it for a much longer time. Okay. So on the intermittent reinforcement schedule, so there are actually 4 intermittent reinforcement schedules, and these are the 4. We'll just go over them really quickly. So fixed ratio schedule is the one that we were just talking about, the one that I was talking about. That's when the behavior is rewarded every certain amount of times the behavior is performed. Whereas variable ratio schedule is the behavior is rewarded after an unpredictable number of times. So gambling is an example. the reason why gambling is so addictive is because we are constantly waiting for that reward. We don't know if it's going to come in one turn if we're playing blackjack. We don't know if we're going to win in the next hand, the next two hands, the next three hands, but when we win, it feels great. So that's really what the variable ratio schedule is. It's just rewarding after an unpredictable number of times because we're looking for that reward. So that also does cause a pretty strong response. A fixed interval schedule is the behavior is rewarded at set time intervals, regardless of how many times it's performed during these intervals. So if I only give my dog a treat every hour on the hour for sitting, it doesn't matter how many times they sit within the hour, they're only going to get it at that hour. And the dog will eventually learn this. So we'll actually, the response to the stimuli that are presented to the dog that are far away from the interval where they're going to get a treat, the behavior is actually not as strong. The response to the stimulus is actually not as strong. And what I mean is, if we are giving our dog a treat at 1 p.m., at 2 p.m., at 2:30 p.m., at 3 p.m., at 1 p.m., that dog is going to sit. I'm going to give him a treat. And then he's going to sit at 1:05. I'm not going to give him a treat. He's going to sit at 1:10. I'm not going to give him a treat until 2 o'clock. When he sits, I'm going to do it again. That dog will start to understand that he is only going to get treats when he sits at a certain amount of times. So he will be less likely to sit for a long time after he gets a treat, because he's understanding that he's not going to get another treat for a while. And then variable interval schedule, the behavior is rewarded at random time intervals. So it's the same thing, only it's not fixed time. It's just at random times, regardless of how many times the behavior is performed, as long as it is performed at least once. So if a boss walks by his office at random times throughout the day, the employee working there will display constant effort. So it's not like fixed interval, where if our boss was coming in every hour on the hour, we would make sure that we are doing our best every single time that boss walks in. We don't know when the boss is walking in, so we're going to have constant effort displayed throughout the entire time, because he may be coming in at any certain point. Little more on associative learning. So shaping refers to the reinforcement of small stepwise behaviors to teach an organism a more complex behavior. Again, talking about dogs, if you've ever taught a dog how to roll over, shaping is a way that we usually do that. You'll usually teach the dog how to sit, then you can teach the dog how to lay down. Then from there, you'll teach the dog how to roll over on his side. And then from there, you'll teach him how to roll over completely. And then, you attach that to one command, and that's basically how shaping works. And that pigeon to the right, that diagram, step 1, we give the pigeon food when it turns toward the button. Step 2, we give the pigeon food when it walks toward the button. Step 3, we give the pigeon food when it raises its head to the height of the button. Step 4, we give the pigeon food when it taps. So we're rewarding little behaviors so that the animal learns this one continuous complex behavior. And then we have two other types of learning. The first one is called escape learning, and that refers to learning a behavior that helps escape an aversive stimulus, obviously. So a child that finds herself suddenly outside in a storm will seek shelter to get out of the rain. So that's kind of like our dog in the rain example that we used when we were talking about negative reinforcement. And escape learning can be negative reinforcement. So in this case, it is. She's trying to get out of a bad situation, so she learns, I need to seek shelter to get out of the rain, and that's how I get out of this situation. Then avoidance learning refers to learning a behavior that helps avoid averse stimuli before exposure. So that same child eventually is going to learn that when she walks outside, if she looks up and she sees dark skies during the daytime, it's probably not a good idea to go outside. So that is avoidance learning. Okay, memory dysfunctions. These aren't super high yield, but the two most common ones are not hard to know, so you definitely should know them, because Alzheimer's definitely does pop up on the MCAT. So two of the more popular ones that they see are Alzheimer's disease and Korsakov syndrome. So Alzheimer's disease is one that slowly destroys cognitive functioning and eventually the ability to carry out activities of daily living. So as Alzheimer's progresses, clumps of proteins called amyloid plaques and tangled bundles of nerve fibers called neurofibrillary tangles. They're also called tau tangles, as in the Greek letter. So these clumps and tangled bundles of nerve fibers, they become increasingly present in the brain, and that's basically how this cognitive decay occurs. It's because of the buildup of these plaques and these tangled bundles. So Alzheimer's is actually currently ranked the 6th most common cause of death in America, and it can honestly be even more. But that's pretty much in terms of the MCAT, in terms of the scope of the MCAT, that's pretty much what we're talking about when we're talking about Alzheimer's disease. Just that one of the main symptoms of it is usually some type of dementia. It is a debilitating disease. It stops cognitive functioning. It stops your ability to carry out activities of daily living. And then those amyloid plaques are super important to know when we're talking about Alzheimer's as well, that they're a bunch of unfolded or misfolded proteins that clump together in the brain and cause issues, basically. And Korsakov syndrome is similar in terms of the dementia aspect. It affects memory function, and it's believed to be caused by thiamine deficiency, which is vitamin B1. And it just has to do with cognitive functioning, with the way our brain processes glucose. So this is most commonly found in cases of alcohol abuse, but it can also happen in other conditions like cancer. AIDS can also cause it. The incidence level of Korsakov syndrome is much lower than Alzheimer's. Okay, one more review time. Read that and pause. Take about a minute, maybe a minute and a half for this one, and then unpause and we'll go over it. Okay. So which of the following are not examples of negative punishment? So our correct answer is going to be D. That's Roman numeral 1, 3, and 4. So let's review all of the Roman numerals. So 1, buckling your seatbelt to stop the annoying beeping in your car. So if we look at what is going on, the annoying beeping in the car is the stimulus. So we're buckling our seatbelt to get rid of the annoying beeping. Buckling our seatbelt is the behavior that we want, and we are stopping the annoying beeping. So that would be negative reinforcement, because the beeping is reinforcing the behavior of buckling our seatbelt. So it's not a punishment, it is a reinforcement. Remember the difference between punishment and reinforcement. It's negative reinforcement because we're taking away an aversive stimulus, which would be the beeping. So when you put your seatbelt in, the beeping stops, everybody's happy. So 1 is not an example of negative punishment. So 1 would be true. 2, a parent takes away their child's video game privileges for a week for not doing their homework. I actually did just use this. I just used this example a couple of minutes ago. So that actually is an example of negative punishment because we're taking something away that the child likes. So that would be an example of negative punishment. A dog is given a treat for properly obeying the word come. That is positive reinforcement. That's one of the easier ones to identify. Dog does something good, we give them a reward. So 3 would be correct, and 4, a cat is sprayed with a water bottle after it stole food off of a plate. So that would be negative. That would be positive punishment because stealing food is a behavior that we are trying to discourage. So we spray them with the water bottle, which would be a punishment. And since we're adding that punishment, it's positive punishment. So 1, 3, and 4 would be correct. The correct answer is D.